All right, hi, welcome to part 5 of our leaf tissue data series. We've looked at nitrogen, phosphate, potassium, and sulfur in previous videos. Today we're going to move to a micronutrient and take a little closer look at zinc. So we will be comparing the leaf tissue concentrations to concurrent Agrimodis testing, which shows you zinc pounds per acre of content, your biomass. So up the left side on your y-axis is your leaf tissue zinc parts per million. The lab sufficiency range for this time period was 15 to 50 ppm. And you see every single sample we have is within that sufficiency area. But one thing that did kind of stand out to me, and I'm going to go ahead and put the bushels on this chart like we've looked at for the other nutrients. The amount of zinc you have in the crop at the time these were taken, and I'll keep that part to myself. But uh, if you have a higher yield goal, then by the time we sampled these, you would need a higher level of zinc, and that's how we can determine these bushels as we go across the x-axis. And what was standing out is this little lower clump of data right here is nothing exceeds 25 ppm. So that one, this is not good. I mean, this is 100 to 160 bushel corn probably right here is what these are representing, and nothing's over 25 ppm. So there are more correlations here to that leaf tissue than we saw with nitrogen, potassium, and sulfur, and that's why the R squared is a 0.21 essentially, excuse me, which is a medium correlation. The same confusion exists though once you get past that threshold, because the majority of these dots in this cluster here are anywhere from say 170 bushel corn up to I'd say 260 is where most of these are. And you won't know if you're at 20 ppm or 25 ppm, 30 ppm, 35 ppm, or even up here past 45. Those are all about 200 bushel corn leaf tissue samples. And you have something similar here when you get to, say, the 225 level. So you still can't manage your zinc based solely off that leaf tissue. You're going to be right more often if you keep it above 25 ppm that you are in a range that is 200 plus, but you still have these that make that untrue. And what I mean is like at 20 ppm, well, that's below our 25 I just said. You could be at 120 bushels, or you could be at 200 bushels. So you don't know where you are yield wise with just the leaf tissue concentration. So at 25, you could be at 170, you could be at 300. At 35, you could be at 170, or you could be at 300. So just more again, the way I used to interpret leaf tissue also, I wanted to keep that zinc up to 25 to 30. I thought that was good, and it looks like that puts me in a category of at least having 160 plus bushel corn, but I can't tell where within that range I am by just the leaf tissue concentration. I need that whole plant information. All right, some information on zinc just from crop physiology and from our studies. Nutrient accumulation of zinc, about 60% of it is to tassel, and then the rest is as you go to maturity. You do have a spike of zinc when rapid growth begins, so your peak accumulation rates early like V10 to V15, and then you have another one that is kind of as your kernels are filling. So just some really rapid times of accumulation of zinc. So you need almost 2 shots of zinc. So it's a good one to put in with a fungicide if you're going out late season, and it's a good one to feed with nitrogen. Zinc and boron, by the way, have about the same feeding patterns. Sorry, we're having this 80-degree temperature swing. I think we're all experiencing. So it's catching up with me. I can't get through a recording without a quick cough. Zinc pounds per bushel are very low. You're talking to 10 thousandths of a pound per bushel. Published is normally 25 to 26 10,000ths. The Agrimodis averages are a little bit less. Now, does that mean that zinc deficiency is that common? And what is the yield impact? And we'll look at that shortly. We did intervals for the sulfur slide, and I wanted to pick that up and show on the zinc slides I hear a lot about phosphorus and zinc ratios, and you never really know what they're talking about, and I'm not sure if they do sometimes, of whether that's a soil goal or whether that's a plant goal, but you hear 10 to 1 from everything. Well, just because you have a 10 to 1 in your soil doesn't unlock one or the other. Just because you have a 10 to 1 in a plant doesn't unlock one or the other. All right. So um, there is a physiological role that phosphate in the presence of zinc is more efficient than if you remove zinc from the nutrient solutions growing in. And that's true. You can find plenty of studies on that. But to what degree, and does it have to be a certain ratio? I don't think so. So when I put those intervals in, I just put the phosphate zinc ratios for each 25 bushel yield interval starting at 175 and going to 350, and I see no clear pattern that that ratio is any different for 300 bushel corn than it is for 200 bushel corn. All right, so just wanted to include that in case you had been hearing a lot of that chatter. There were patterns in the ratios of zinc to copper and lesser, but it exists for zinc to moly. So whether or not that is anything of importance, we'll find later with regression analysis. But just wanted to throw that information in there on top of the rest. So for Agrimodis, we had about 70% of the samples show some sort of zinc deficiency, although most of the time it was really, really low. And 30% had an excess amount of zinc. Relative yields up here in this chart, the green is your no deficiency, no excess column. You had 100% yield at that. As you drop to a negative 0.1, or if you increased zinc to an excessive 0.02 pounds, you did have a little bit of a yield wobble by about 1%. And then as you kept going on the excess or you kept going on the deficiency, we saw that yield drop off. Now, there weren't very many samples at all down here at this negative 0.3, negative 0.4 range. That's a pretty severe zinc deficiency. But when you're looking at the negative 0.1, negative 0.2, here's where a lot of the samples came in. Bushels, like say this is 200 bushels here on the zero bar, this would lose about just under 3 bushels. This would lose just a little over 6 bushels. So there is a potential that zinc could be affecting your yield. The average deficiency was a negative 0.156 pounds. Now, what does that mean? That's about in the way of a fertilizer equivalency. It's almost a half pound of zinc sulfate, your 35.5% zinc sulfate. In equivalent terms of, say, a 9% liquid zinc, it would be about 20 ounces would encompass this negative 0.156. If I put all of the zinc samples all together across everything from VT to maturity, I was actually at a positive 0.063. So it would be kind of in this realm over here. Okay, so if we get rid of that excess, it looks like the yield may actually increase a little bit. We get rid of the deficiency, same story. So for every tenth of a pound low, that's about 13 ounces of a chelate. Okay, so you can put the dollars to that and see what makes sense. So, all right, so there's zinc in a nutshell. That's all we're going to cover on it. And we'll look at a couple more micros in the days to come. Thanks for your time.